Right, in this demo we are going to do frame dissector. For that, let me quickly open the Wireshark. Now what I'll do is I'll quickly open another browser where I'll go and say incognito mode www.yahoo. Come. Right. So now let me stop the capture. Almost 10,000 packets have come. Now I need to locate the exact capture in the Wireshark which I need to see the frame of that which sent a request to Yahoo. So let me use a capture filter. We are going to deal with capture filter in our next section. We are going to see the display filter. We have seen capture filter under the interface level. We tell what to show in the Wireshark, what to capture by the Wireshark, and what to filter. This is now display filter. I'm going to use this location where I can use a display filter and say, show me all those packets that has got Yahoo as a string. Frame contains Yahoo. Frame contain Yahoo. Oh, too many. Here is the first one, DNS request to Yahoo. You can see here, DNS request to Yahoo. Last time when I was trying this, I was not able to see Yahoo. It was showing in the Microsoft server, the web server, which was caching the Yahoo page. That's why I was not able to dig deep. But now it shows from the Yahoo itself. That's the query to the DNS. And then we got the query reply here. The query reply is the answer for the Yahoo's address. This is the Yahoo's address from where the Yahoo page can be retrieved. Let's try one more. Let's say Facebook this time. Wireshark, and I'm going to capture the Ethernet, and then I'm going to say Facebook this time in the incognito mode. Facebook.com. I got the Facebook page. And let me go down to stop the Wireshark. And then now I want to use the same thing. Frame contains Facebook. Alright, only this much. You see, you got two DNS, and then you got facebook.com, and then we can see. But it is encrypted, so it is TLS, transport layer security, say HTTPS 443. You cannot see the page. If you wish to see, this is the way that we see, like follow TLS stream or HTTP stream if it is available. But it is totally encrypted, so we don't see anything here. Or let's say follow this is a client hello. Application data. Let me see coming from here. Yeah, this one. Follow TLS stream. Nothing. Let's see. TCP stream. Yep, this is the page that it was showing you, the facebook.com. More about this we will see later. So we are able to use this filter, the display filter. Let's do one more page. I'll stop this and then I'll open another one. I'll put demonstration.com, and this is an HTML page. I should see some HTML feeds. Now let us go to once again I'll refresh this. And now I'm going to say frame that contains domain.com. Something is wrong. Contain. Let's see this one. Big rock. Big rock. No. Domination. This time it should work. The spelling is right. Yep, here we see. Let me try to do one more time so that I can capture some HTTP. Try to open fresh. Okay, so let us go back. Let me see, something should be there for us. Earlier I saw HTTP. All right. No HTTP. So in case if we have one HTTP page, we will be able to right click and say follow and HTTP stream, that you can see some more information. Right, I managed to download a sample capture. Now if you see here, when I right click on this, I can see follow and then HTTP stream. And what does it say? It says Apache server coming from there. That's the destination. You can see the text size, the HTML format in which the windows have been designed. So you can follow up for more details like this. So what other thing I want to show you is, as per the IEEE standard, In the Ethernet section, if you see the frame section, frame dissector is what we are seeing. You can see the destination MAC address first and then the source MAC address, and then the type to tell the receiving device that it's an IPv4 packet that is coming, not an IPv6 or an FC traffic. It says it's an IPv4 traffic, which uses IPv4, the 32-bit address traffic that is approaching you. This is as per the standard. So as per IEEE 802.1.3, the destination IP address with 48-bit followed by source MAC address, or destination MAC address followed by source MAC address, and then the payload. We will talk about the layer 3 payload in some time. Now the next thing is, if you see, there is also a preamble which is always attached the start of the frame, but it remains the same for all the conversations, so it's not captured by the Wireshark. The start of frame never captured by the Wireshark. Next is the IP packet. If you see the IP packet, we got the IP header like this. The version means 4 or 6 or IHL, and type of services, the total length, the important fields, TTL, the protocol, source IP destination. This is as per the standard. Let's now go to the Wireshark and see how it looks. So when we open this Internet Protocol field in the Wireshark capture, we can see the same order what you saw in it first talks about the version and the length of the the header length and the differentiator service if it is QoS configured, and then the important point is protocol. Protocol field shows what protocol is that used in the next layer, the transport layer. Like we saw in Ethernet, the layer 2 says that layer 3 is going to use layer 4. Likewise, layer 3 says that layer 4 is going to be a TCP based layer 4, and then the source IP address, and then the destination IP address. So it's organized in the same way as it is shown in that presentation which I showed you, according to RFC 791. That's right, RFC 791. It's exactly the same manner in which the messages or informations are listed here. So these are the things that we can see when we do Internet Protocol Dissect. The next is TCP Dissect. So what we see the same like what we saw in layer 3 header. In layer 4, as per the RFC, the first comes the source port number. RFC 793 says that, and the destination port number, then the sequence number, acknowledgement number, offset, checksum, and so on, padding and so on. Let's go to the command and let's go to the Wireshark and check this. See, we have the source port number in the first, and then the destination port number, and then the stream index is 0. If you have consequent TCP sessions, you will have the stream index incremented given by Wireshark, and then you also have the sequence number 0. It's a relative sequence number, it's not the original sequence number. Wireshark provides a sequence number for us to easily follow the small numbers, and the original sequence numbers will be like this. For this sequence number, there's the first packet, there is no acknowledgement. And then let's get to the next packet. In the next packet, we see an acknowledgement. Earlier, the sequence number was, look at this, ending with 39. The next sequence number acknowledgement should be 40. Yeah, acknowledgement is 40. And you see the earlier sequence number was 1, the relative, and the acknowledgement for 1 is received. So you can follow either this sequence number, the relative sequence number, or the raw sequence number. The sequence number are the one which can be used for attacks, so it dynamically generates a random sequence number for every 3-way handshake. That's why following a raw sequence number is easier. You see now the fourth packet sends the sequence number, the relative sequence number is 480, and for which we are going to see an acknowledgement the next packet, relative acknowledgement 480. The next sequence number is going to be 1, and acknowledgement 1380, because the previous one sequence number was 1381. So either you can use the Wireshark given the relative sequence number and relative acknowledgement number, or the raw sequence number, the raw acknowledgement. Right, and now when we go further down here, when we click on the flags, we can see all those flag messages that are turned on. We can see it's an acknowledgement packet, acknowledgement flag on. What we see is the Wireshark is interpreting things as per the RFC. And more detail about this TCP header we will be seeing as a separate topic under TCP with the Wireshark. And the next field down here is the layer 4, means the, let me go up to HTTP. Right after TCP, if you go down, you will see another portion, HTTP. After TCP comes the HTTP, where you see the host to which the packet is up to, and a lot of other information. This is more complicated than the layer 4 TCP. This is application layer. Right. So in the next, what we are going to see is we are going to use this Wireshark to decide the MAC address. Very easily you can know the source MAC address, your own MAC address, your gateway MAC address, here, your own MAC address, your gateway MAC address, and then your own IP address and the final destination IP address, and the port number, the source port number, then the destination port number. You can easily use this Wireshark captures to draw a topology with the informations like IP address, MAC address, and port number.